you again for joining me. You're welcome back to another session with your own educator. Yeah, today, as you can see from here, we're considering um, construction of our histogram, representation of our data. Of course, this data is grouped data, representing it on a histogram, and from that histogram, we determine the median and the mode. Now we have been given these two things. We are given the class marks and we have been given the frequency. So we have this, and from there, because to represent this on the histogram, we need two important things. We need the class boundary and we need the frequency, where the frequency will be plotted against the class boundary. Now to get your class, where I get my class boundary, you deduct 0.5 from the lower class mark, which will give us negative 0.5, and you add 0.5 to this, that will give you positive 0.5. So this should be positive 0.5. Then you continue, we add the same thing here. 10 to 19 give us what? Subtract 0.5 from here, have 9.5, add 0.5 to this, 19.5, as you can see. Then from here, you can equally see that our frequency is given for the corresponding class marks. Then the class size for each of them, they are all 10. They are uniform. So this one too is 10. The class size is 10. Now, what do we do with this class size? The essence of this class size, I wrote them out because you should know from 0 to 9 is 10. When I say from 0 to 9, I mean it's 0 to 9. What are the numbers that we have? We have 0 first, we have 1, we have 2, we have 3, we have 4, we have 5, we have 6, we have 7, we have 8, we have 9. Altogether, what do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the class size is 10. And that is uniform for every other class. So what does that mean? You can just go straight to plot your frequency against your what? Against your class boundary. What happens if our class mark is not uniform, such that it affects our class size and they are not uniform? Then you have to go and generate a frequency density. Yes, generating a frequency density will help you to work around this. So to generate a frequency density, you can easily maneuver all this and you'll be done. You get. So let's generate a frequency density. A frequency density is always your frequency divided by the class size. Okay, so where you have this already, that means if your frequency is 3 now, the frequency density for this class will be 3 divided by 10, that will be 0.3. If this one should be 0.7, if this one is 12, that let's say this one is 13, so the frequency density for this class will be 13 divided by 13, that is 1.0. So it's now frequency density, we now go and plot against your class boundary instead of your frequency. And that happens only when your class sizes are not uniform. Get? Once they are uniform, you are good to go. Just like here, we are good to go here. So thank you. Now plotting this, our frequency we have 1, the least is 3, the maximum number there is 10. So probably we should just have 2 to 14. Yeah, 2 to 14 is 0. We pick this as 2. Okay, let's pick up as 1. This is 1. This is 2. If this is 2, what do we have there? Pardon me, let me add up my network so it become easier for me. This is 2. This is 2. This is 2. Then we have this to be 3. Next line. We have 3. We have 4. If this is 4, then the next number we have 5. Okay, probably let's keep skipping this. Apology for so I have the 4. This is 6. So this is 8, and this is okay. Let's start the calibration again. Avoid errors. We have 4, and we have 2. Probably let me make it 4. Yeah, I think that will be easier for us. Yeah, make this 4. 4. And this place to be 8. And this place to be 12. And this place to be 16. So we have that. And let's just have the bars that way. We have them that way. What do we have for the class boundary? Negative 0.5 to 9.5. Negative 0.5, you can't go from here, so we should just have something like this. Okay, should have started from here anyway. So from the negative side, something like this indicates that it could have started from there, but we just need okay, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I'm going to start from here. So I can still do something. Okay. So it's not starting exactly from this source. Don't forget this is 0.0. This is 0. So if that is 0, that is 0, then we can go from here. Then our bar will be drawn from this 0.5 to 9.5. So our 9.5 is somewhere there. There. Then we go. Is 1 into 9.5, and it's stopping at 3. So this is 3. Let me trace my 3 out. Let me just trace it. So I have this John. That's my 9.5. To go to the center here. And I have the next one. 10 to 19, 9.5 to what? To 19.5. Okay, I've not calibrated this part. Let me write. This is my 10. This is my 20. This is my 30. This is my 40. This is my 50. You get it? Now for my 9.5, 9.5 is still here. Probably I make this a bit straight. Go to 3. This is 3. That is my 3. Don't need this side actually. So that's my 3 corresponding to 9.5 and 3 to 0.5 to 9.5. And the next one 9.5 to 19.5 is my 19.5. The center here, but the question is where is it going to? To 7. So this is 8, automatically this is 7. So I should go from here. Go from here to 19.5. That's how I should move. And that is another one. Then after that we have what? We have 19.5. That is 13. This is my 13. Then it should correspond to 19.5 to 29.5. 29.5 is somewhere here. 29.5. So I have from here to here. Somewhere. So I move. Please. So let's illustrate. So we have that already. I haven't gotten that. So we have that. Let me leave it. So I have what again? I have 29.5, 39.5. This 39.5. This 39.5. Then from here is what 8 is at 8. So that one should have been each 13 is 14. 16 should have been 13 here. So I have to draw this again. Okay. The 13 should be here. That's where I should use 13. So I have 13. Use 13 to have this. So I have that. 13, then we have the other one. Have there. Then we have 8 to this is my 8. 8 to this. So what do I have here? 8. 8. We have 39.5. And the last one we have is 10. 10, 39.5 to 59.5. It's 8, 9, 10. So this is 10. So I haven't gotten 10. That's my 10. Yeah, I think I'm good to go now. Can remove all this. I haven't done that. What am I doing next? The question says calculate the median and the what? And the mode. How do I calculate the median? Two things are important now. I will go to this place. I will look for just like the formula for finding median, the median position, summation of f over n. What's my summation of f? This is 3 plus 7, 10. 10 plus 10, 20. 20 plus 13, 33. Yes. 20 plus 20 plus. So I have 10 plus 13 plus 18. Everything is 41. So I have 41 divided by 2. Sorry, here should have been 2. It's supposed to be 2. And that will give us what? Divided by 2. That is 21 divided by 2. So I have 20.5. Now this 20.5, we are going to use it to do something. Just go to your, we need two values. The first value will be this. Write this 12.5, then add your frequency before the median class. We know that now if summation of f over 2, this one is for getting the median position, is position. So the median position, if you add up, let's see where we get 20.5. 3 plus 7 is 10. 10 plus this is 23. Automatically 20.5 will fall in this class. Since this one is 23, from here adding up. So these are median class. Our median class is this. This is our median class. I see that that's the median class. If that's the median class, then go and add the frequency before the median class. Frequency before the median class is what? 3 plus 10. And that is what? 10. And 3 plus 7 rather. That is 10. So you're going to be having 20.5 minus 10. And that is 10.5. We're going to be using this 10.5 soon. Then go again, go to another value. We need another value here. What's the other value? Go and find the cumulative frequency after the median class. Or sorry, cumulative frequency of the median class. 3 plus this, 7 plus this, 23. So I'm going to write 23 minus, what do we have as the median position? We need that median position, minus 20.5. So that we use the 20.5 here, we subtracted the frequency, summation of the frequency before the median class. Then we came here, we use the same median position. We are now subtracting it from what? The cumulative frequency of the median class. That's what we are doing. And that will give us what? We have 23 minus 20.5. That will give us 2.5. Add our values. So what are we doing with these values? We are going to use these two. We have 10.5 and 2.5. We want to know what we get as we want to divide this median. This class is the third class. So this is our, this place, this is our median class. So we want to come to this, what do you call it? This bar, and divide it appropriately in this ratio. We take this as ratio 10.5 ratio 2.5. So with this will be now, how do we get it? It is 10.5. Let's know how we can apportion it. How many lines are there? We have about 10. Let's see what we have. We get this into order. How many we partition? How we can partition this bar into this ratio? How can we do that? Let's go and find the value that is appropriate for this ratio and the one appropriate for this ratio. And how do we calculate that? For 10.5, you have to write 10.5 divided by 10.5 plus 2.5, that should be 13, times, what is the class size of this? What is the class size? The class size is what? Is 10. Times 10. So our answer should be 105 times 10. That is 10.5 times 10. That's 105. So 105 divided by 13. That's 8.07. Approximately that is 8. Right? Permits me to clean this place. If I wipe this place, what am I going to be having? So let's see. trying to teach something. Okay, we have this. Let's say we have this now. So now let's calculate for 2.5. How am I going to do to get 2.5 ohm? Let's just clear this part. To clear this part, I'm going to be having 2.5. Don't forget we got 8 for the first part. So let me clean this place too. If this place will now be apportioned into 8 ratio, I don't know the ratio yet. So let's calculate for this one. This one will be 2.5 over 13 times 10. And that will be 25 divided by 13. 25 divided by 13. That's 1.92. So 1.9 is approximately 2. So this means this should be 8 ratio 2. That's what we need to divide this into. Divide this into 8 ratio 2. That's what we are doing into this bar. So how do we get that? That's the next question we need to ask ourselves. How can we come about that? What do we do to get that out? I think it's straightforward. All we have to do is make sure we count. It's counting that it's left now. So what do we count? We need 8. This is 0.5. So from here, this is 1, 2, 3, 4, 5, 6, 7, 8. So to get the 0.5, this is 8. We have a 0.5 behind. So 1, 2, 3, 4, 5, 6, 7, 8. I'll come to this middle. This is the middle I need. So this I've partitioned it. I've successfully partitioned it. Let me just draw a straight line down. Yeah. So I've divided into, this is our mean. This point is our mean. Median rather. This is our point. This point is our median. If this point is our median, what are we going to have? This place, this line, this is 19.5, this is 20, right? This is 20, 21, 22, 23, 24, 25, 26, 27. So our median is 27.5. Let me write that. Median is 27.5. So median is equal to 27.5. How do we calculate our mode? The mode is the simplest. Just draw a straight line like this. I would like to get a straight line. Let me see. Let's see if I can get a straight line. I just need a line. Okay, it's like I'm not getting a line, but so no problem. If I'm doing that, I will just draw a straight line from here. I will draw a straight line. Okay, yeah, let me use this. If I draw a straight line from this point, perfect. Then I draw another one from here. Draw another one from here. Draw another straight line from here. Very good. Thank you very much. Oh, I don't want this. It's not straight. 7. It's not straight that time. Okay, good. I think it's okay. So I have this now. Back to this. Where's my mode? The mode after crossing, because why did I pick this bar? This bar has the highest frequency. Obviously, our median class is also our modal class. It's the one with the highest frequency. So this bar will deal with. And I go to the bar, the two bars beside each other. This bar and this bar. I go to this, I draw a diagonal line here. I draw another one here to this end. Then I go to where they meet. This is where they meet, right? Where they meet, I draw a straight line down. This is where they meet. So if this is where they meet, I can use this. Okay, let me use a black line straight arrow. Trace this down. Trace this down. So I have this. It's just a straight line down. So what value is this? This is 20, 21, 22, 23, 24, 25. My mode is equal to 25. So we have been able to generate our mode and our median from this graph. You can replicate it in your own book or your own graph book and practice it. Yes, thank you very much for joining me. I remain blessed.